Last one in this section. I want to evaluate this limit. It is again, this integral. It is again a improper integral, not because I've got, usually, often with improper integrals, it's because I've got infinities here or here, right? But this thing clearly should, to you, have an asymptote, a vertical asymptote, at x equals 1, because it's undefined there, right? So it's going to have a graph that's going to go like this, at 1 potentially like this, right? It's going to have that vertical asymptote. So I need to use improper integral techniques because it starts at the 1, which is where that asymptote is. So I need to look at this as we'll do some scratch work down here. I need to integrate, I'm going to write it as x minus 1 to the negative 2/3 power dx, which is going to bump up the power, so I get x minus 1 to the 1/3 power, but I need to divide by 1/3. I need to divide by this number right here, which is going to give me a 3 there. So I could rewrite that as 3 cubed root of x minus 1. So I need to look at the limit as a approaches 1 of this thing, 3 cubed root x minus 1, evaluated from, well, a, because that's my 1 that it's going to. And I could say 1 from the right if I want, but it doesn't matter in this case, to 3. So, as I go to evaluate this, maybe I'll do this guy in green, this guy in red. So the green part is what I do first. So this gives me, I can plug in 3. It's easy. I plug in 3 to this thing. I get 3 minus 1, which is square root of 2. Got to put the 3 out front, so I get 3, not square root, cubed root of 2, minus, and then I need to plug this guy in, or imagine the limit as a approaches 1. Now, oftentimes when we deal with limits, like in the previous question, you can't actually plug a number into the expression. But with this one, I'm looking at the limit as a approaches 1, and I can actually plug 1 into this. So since I can plug 1 into it, the limit becomes very easy to evaluate. I just plug it in. So as I plug in 1 to this thing, I get 1 minus 1, which is 0. So I take the cubed root of 0 and then multiply it by 3, and I just get 0. So my answer is then going to be that 3 cubed root of 2. That's all there is to that one.